Can you enable screen sharing?
Of course I can.
Great. So I'm going to share my screen, and please let me know if you can hear me properly and see the screen properly.
Yeah, we can see your screen. Go ahead.
Okay, great. So yeah, so I have a couple of topics, under the same umbrella for today. So essentially, I'd like to share a new project we've been working on since the beginning of the year. It's called AppWrapper. It's built on a lot of years of experience, but this part is really from the beginning of the year, and this is a new CRD and controller we've been designed specifically to work with Q and to enhance queuing capabilities. This joint work with other colleagues at IBM Research. And so we're very much looking for feedback on, I guess, two parts, right? I'm going to explain, why and what and how we're doing this. But we're also looking for feedback on this, but we also have some feedback. I mean, we're not the first one, obviously, to build something designed to work with Q, but there hasn't been much of that going on outside of the core, I guess, Q people, and therefore we'd like to share some insights, some challenges, and some discussions about how we think this can be improved in the future. Not, more broadly than just a piece of work we've been going after. Right. So and again, feel free to interrupt me, questions and everything, right? So the background for this is we are the team in IBM Research that is essentially has been responsible for a while for batch scheduling for AI systems, in particular the clusters in which we do large language model training. And so we've designed and implemented our own system for that over the many years, at least the last 5 years as an open source project. It's the MCAD project, multi-cluster application dispatcher. Recently, last year, we built a V2 version of that project, which is currently what we actually use again in our cluster to do batch scheduling for these workloads. But what happened in the meantime, obviously, is that Q happened, right? And we're very interested in Q. We think it does a lot of very interesting things. It solves some problems we never went after, like implementing resource flavors. There's a community behind it and so on. So we'd like as much as possible to transition over to Q, to leverage Q, and at the same time also to contribute to Q with the experience and the capabilities we think could be very useful to Q. We're also very interested in multi-Q, but that's a separate discussion. So, but when we look at Q as it existed today or existed 6 months ago, we found some gaps between what we are used to do or what our users are used to do on our clusters and what Q supports, or not just Q, but Q plus all the CRs and CRD it supports, in particular jobs and job sets, right? And the two I want to talk about today are bundling and unsupported kinds, right? So the first thing that people do is they want to bundle different things together, something like a Python job, which obviously Q today supports, but also configuration information like secrets, config maps, service accounts, routes, all kinds of other things, right? Plus sometimes they want to bundle multiple jobs together, where job doesn't mean actually a job, but means a kind of job like a Python job or a job or something like that. And the second thing is we also have a lot of use cases where we continue to use, let's say, maybe legacy structures for describing jobs like deployment, stateful sets. That's still very common. The arguments of why, transitioning over to job might be a good idea, but that's the reality of it. And there are also maybe use cases such as queuing in interactive development and debugging sessions where it makes perfect sense to use these resources in the first place. So this is not something we can do with Q today. We try to engage with the community. For instance, I included a link about a discussion we had about job sets to discuss whether our job sets could be extended to go beyond jobs, being beyond just a set of batch V1 jobs to be other things. And the feedback we got from the community was more or less no, job set is what it meant to be. And if we need something different, we should go build something different. So this is exactly what we've been doing. Building this new AppWrapper CRD and controller. That's an open source project. You can find, Apache 2 license. You can find the source code. You can find the documentation, etc. And at the high level, the idea is an AppWrapper is going to be a workload, and a workload is going to be a collection of Kubernetes objects. And also, you can think of these objects as being two kinds of objects. Some of them create pods, some of them don't create pods, essentially, right? So you have configuration objects. They can be anything, really. It doesn't matter. And then you have compute objects or objects that create pods. And what we're proposing here is a generic support for things that are built on top of pod spec templates, which is a very common way to build custom resources, for instance, deployments, stateful set, PyTorch jobs, RAID jobs. All of these things are built using pod spec templates as the mechanism to, at the end of the day, describe what the pod will be. And it's very important for Q because Q has expectations in terms of recognizing the pod sets in a resource, mutating them, inserting labels, stains, toleration, etc. For instance, particular to implement resource flavors. And so that's very important that we have not an entirely black box view of a resource, but in between things that says it can be anything, but this anything has to follow the structure. And the idea there is, again, an app wrapper will be all the things in an app wrapper will be jointly managed, so they will be acquiring quota together as an atomic thing, as a wall. They will be dispatched together. They will be suspended together. They will succeed together, etc. Just like a job set for jobs, I guess. So here's a very simple example of what an app wrapper looks like. Hopefully you can see all of these. So it basically is very, very simple. Again, it's a custom resource. Of course, it's going to have an annotation that describes in which queue we want to queue these particular objects. Of course, it has a spec.suspend field, which is not shown here because it's intended to be managed by queue and not by users, but it's there underneath so that queue can manage the object. And essentially the content, the spec of that object is a collection of components, so an array of components. Each one of these components is as a template, which is the resource we actually want to deploy. Here I have just an array of one, and this one is a deployment. And in the case where we have a resource that is creating pods, then there's a very important piece of metadata, very short but important piece of metadata on that template, which is a list of pod sets contained in that template. And that list, first of all, repeats the number of replicas that you're going to have of these pods templates, pod spec template. And the second one is where to find the pod spec templates inside the resource, right? So for instance, if you have a deployment, we say that if you go template.spec.templates, you will find the pod spec or the pod template spec, to be specific. That is what eventually deploying these resources deploying this resource will cause the creation of these pods, right? So today in app wrappers, you have to, and in general, you have to provide this information. In the very near future, we expect this list of pod set will be automatically generated for all the typical resources that we want, because if we have a deployment, we know exactly where to find this, and we can automatically generate that piece of metadata. Make sense so far? And so, of course, the point is you can have multiple of those. And again, if you have a pure configuration resource, one that doesn't create pods, then the pod sets is going to, is optional. The pod set in that case, metadata it will not be there. So if we have, so that's yes. Please go ahead, Marcin.
One question about the template. Can it contain an arbitrary object, like some very custom CRD, or do you have a limited set of what is supported?
Yes. So it can, so for instance, to take a simple example, if you have a Spark job with the Google operator that is eventually going to create pods, but is a completely ad hoc custom way of describing the pods, then we cannot contain it, because there's no way we can, generically, without knowing the details of that particular CRD, go and extract the pod set and mutate the pods and add labels on the pods, right? Okay. So there's a path where we could think of adding ad hoc things to app wrappers. For instance, Spark is one we're actually considering doing, but at that point, it's not clear that it makes more sense to do that in an app wrapper than doing that just with the native resource itself, right? The question is who controls the code, I guess, to a degree.
Okay. That part I get. Second question, if I may, do you validate anyhow the content of template?
Yes. So let me skip to how we do this, right? Which starts by answering.
So okay, wait, don't worry. Go with your presentation. If it's further,
yeah, I mean, we do validate, right? So what we validate is a bunch of things. We validate that if you specify a path to a pod set, the path is valid, and what's dangled at the end of the path can be parsed as a pod spec template. If we find that your path doesn't point to a pod spec template, we are going to reject, to fail validation, to fail admission for this particular wrapper. We also, very importantly, validate RBACs, right? If you, as a user in your namespace, you cannot create a deployment, then if you try to put a deployment in an app wrapper, our validation webhook will verify that you're entitled to deploy deployment on the clusters. And if you're not, the app wrapper will be rejected. So we have, we have security, right, in this bundling mechanism. We also enforce, typical things like immutability and so on. So you cannot make meaningless changes to the specification of your app wrapper once it's been created. This kind of things. So, and that's, yes. So the implementation of all of these is a combination of webhooks and reconcilers. So the validating one is the one that really, hopefully answered your question, or let me know if you needed more on this.
I think it answered the question. So you're validating pod template that is embedded in the template.
Yes.
The rest is not validated because you don't know exactly what it is.
Yes. The rest, I believe at this point we validate, I believe we validate that we can parse the resource. I mean, we do some syntactic validation. We do, I believe, pool we validate that I can come back to you to exact specification. It can be strengthened, right?
Not that important at this moment. Don't worry.
There's a question about whether we want to dynamically pool the API that are deployed on the cluster and validate against the API that are deployed on your cluster. But yes, the key is validated. I've already said that, so let me not waste time and repeat. So that's the first part of the webhook. The second part of the webhook is this mutating webhook that is expected of any, Q native or Q compliant controller, which is the automatic suspension on submission of the object. So we have a mutating webhook that when you submit, it inserts the spec suspend true when a proper controller is deployed with Q, configured, and so on to do that. And then the controller itself consists of 3 reconcilers. 2 I'm sure you're very familiar with. The third one, which is maybe the topic of the second half of the discussion. So first, we have an app wrapper controller process, something that you would have if you run app wrappers without Q, because that's actually also a use case we have, right? And so what it does is manages the life cycle of an app wrapper like any Kubernetes operator. So it does the creation, the monitoring, the deletion of these wrapper sources, and all the things you expect there, just like a job set as a job set controller that is separate from Q, right? That's the very same thing. It also, like job sets or PyTorch job or Ray job, as a workload controller, which is essentially this reconciler that runs for the types I've just said as part of the job controllers that are embedded in the upstream project in Q, and that's essentially following exactly the same structure. And app wrapper implements this generic job interface that Q APIs offer, and we call new generic reconciler factory on top of that, and we implement in that small piece of code the things that make it possible to mutate the pod sets, to compute the quota required by an app wrapper, to report whether the app wrapper is ready or not. I mean, the half or dozen, I guess, API methods that Q is expecting to be able to manage the workload objects associated with the app wrapper, right? And so what I should say is that these today exist in the app wrapper repository, but what we very much would like to have a discussion with you guys is to actually upstream that to Q, just like, job set is that part of the job set, story or equation is part of the upstream Q project. And finally, and that's the piece where things get a bit interesting, is that we also have, just like job set, but differently, I'll get to that. We have this need that because we're building something that's composites, but that's a bundle of resources, we have this need that when we unbundle the resource and we deploy the resource, we want the children to be considered special by Q. Q has to understand that they belong to parents, and when we decide to dispatch the parent, then that means we dispatch the child, and the child shouldn't be itself queued, and the quota for the child shouldn't be counted separately because that's going to be double counting and so on. So I'll give more details about that in a second. And today that's a separate reconciler that we have, and I'll explain why. So, we have user documentation. I mean, it's all work in progress, but we have documentation, user-facing documentation. We also have developer-facing documentation. So, for instance, this is the picture we have for explaining the life cycle of an app wrapper, the different, phases, and when, the effect of, suspending and unsuspending the app wrapper has on these finite state machine, and so on. If this is the entry point for the documentation. Again, I gave this link before. You can go and have a look. Again, this is something we've started. We started building this user-facing thing maybe a week ago or 2 weeks ago. So it's very much a work in progress, but it's progressing very fast. So now, if still have time, I'd like to just focus on this specific question, which is how to admit child workloads, right? The sub-resources of the parent resource, right? The reason being, we're not going to use an app wrapper to wrap a PyTorch job, but we are going to, for instance, as I said, use an app wrapper to write a secret and a PyTorch job together, right? And a PyTorch job is configured to be, PyTorch job is something that Q normally supports and Q, and particularly in our system, we're going to configure Q so that, objects have to belong to a queue to be dispatched. Otherwise, this is like this strict queue mode where we say something, we cannot bypass the quota. Something that doesn't specify the quota is running against is just not going to run. So a wrap resource should be admitted by queue when the app wrapper is, and very, very important point for us, that's this mechanism shouldn't be susceptible to abuse, right? So conceptually, we want all the children resources, all the sub-resources to be like logically associated with an infinite queue. That would be a solution, right? We could have all the sub-resources go to a queue with an infinite quota, and therefore, queue would do the normal stuff, and the resource will be deployed and so on. But if that infinite queue can be abused by users that go and actually submit workloads against the infinite queue, then we lose. Right, so we need something better. So we looked at different mechanisms to do that based on our understanding of the code base, discussion with people that, in the community. I had a long discussion, in particular in the last KubeCon about this, and we found a bunch of promising solutions, I guess, that didn't work. And the first one is the queue as a parent-child relationship already. That switch from using annotations to honor references in recent versions, it doesn't work for us. And the reason for that is, there's multiple reasons for that. But the first reason is it actually assumes that the adapter for the particular kind is in the queue repository. Because essentially it bottom-ups to calling get callback for owners, which is not something that can be dynamically extended when we add new resource kinds to queue. It's just the built-in support for PyTorch and other things. So we cannot use that. Moreover, the code that take advantage of this relationship doesn't really do a bidirectional synchronization of the suspension of the parent and the child. It's just one way. And so as it exists today, again, it doesn't solve our problem. We look into composable job as, again, a promising abstraction that is in queue. But as far as I understand this, it's really for pods and nothing else. We looked at what job and job set do, and we found that there's the premise of a general mechanism there, which is also discussed, but the reality is right now it's hard coded to only work with jobs and job sets. So none of these, and we had I should have said before, we had a important requirement to start with, which is to try to build something without having to fork queue, right? This is really, we don't want to have to rely on a hack of the upstream project to do any of those things. We'd like to get to a better state by having a discussion with you and making the upstream project a bit more flexible and rational about this thing. But as it exists today, we really were looking for a solution that wasn't depending on any upstream changes. And so what we ended up doing,
I have a comment here. the idea of extending the parent-child
Yep.
references, that's something that was in my mind, but we never implemented because nobody asked for it.
Yep.
But
And we're
it's
asking.
something that we, yeah, something that can, the easiest path, in my opinion, would be to add a configuration field in the configuration API saying, this GVK is allowed listed for as owning something or being owned by something else. So that could be the lowest friction
Okay.
path.
So
now, responding to composable jobs, yes, it's targeted at bots again because that's the only case we were aware of so far. It doesn't mean it cannot be extended. But yeah.
oh, so that's exactly the sequel to this discussion, which is to actually hopefully agree on an API, a general or generalizable API and a spec for this, something that will be stable. We can rely on not just our wrappers, but anything that tries to do bundling like this. And I think this would be really nice. And again, we have some ideas, but just like you said, I mean, it's really, our main idea is to bring this to your attention and to get together and work out some solution. At the end of the day, we are not, if you have strong opinions about what the solution should be, that's great. So just to point out.
Sorry, I also have a kind of like an alternative design, specifically for things that we already support. For example, PyTorch job, right? We already support PyTorch job. So maybe an alternative approach would be the user sends a PyTorch job alongside with an app wrapper, where the app wrapper doesn't have any compute information. It only says I'm related to this PyTorch job, and then I have all these secrets, config maps, and so on and so forth. So
reverse design.
Yeah. So Q would queue the compute, and the app wrapper would detect when Q has admitted the job, and then is able to create the rest of the things.
So that's plausible. I mean, that's so we have cases where we have, for instance, for bundling two deployments together. So we have cases where more than one compute object there, because, for instance, we have cases where people have a deployment for the head node of something and then a deployment for the worker nodes, and that wouldn't cover that case. So I definitely see what you're saying makes sense, but I think it would be for us, it wouldn't cover the use cases we have, this last option. Yes, let's put it. So just to point out how we've done this at this point in time. So we do exactly what I said earlier. We kind of pretend that the sub-resources are submitted to a local queue that feeds into a cluster queue that is infinite, right? But the trick is to not actually have such queues on the cluster so that they can be abused. So the way we do that is we label the wrap resource with this fake local queue, but then we have a reconciler that essentially acts as this fake cluster queue, right? And so what it does is it first watches for workload objects for the sub-resource, which may or may not exist, because maybe queue manages the type of the kind of the sub-resource, maybe it doesn't. So if the workload object never appears, that just means that queue is not in charge. If we see the workload object coming up, this is when we intervene and we essentially admit this by mimicking what queue does to admit things to a queue. I have details here if you want, but without having the matching cluster queue, right? And we do this watch only for optimization purposes. We do that until the point where the object is ready, in which case we know that everything has been admitted, everything is fine, and we don't we don't watch things just like you. Once things are deployed, we kind of forget about them from that perspective, right? And if you want the full details, we do the pod set patching at the app wrapper level rather than the sub-resource level. These are like minor design decision, I would say. But the point of all of this is we have a solution here today, but I would say this solution relies on private Q APIs, right? This solution might suddenly break with the next version of Q, and we really very much want to avoid that. And we think the solution to that is to together agree, and we can lead, we can follow whatever on a possible design, on a forward-looking design for this particular capability, right? And so if I stop here and want to summarize, because I'm pretty much on the time I hope to achieve. We have this new thing called App Wrapper. We think it's great. We think it extends Q. It's been specifically designed to bring over capabilities that were missing without overlapping with Q, right? So we think it's very useful to us. It could be useful to more people in the community. Again, we went through this discussion beforehand about understanding whether we better extend something existing, better build something new. We build something new because this was the feedback we've got from the community. It does a number of things. The two I've talked about today are about resource bundling and support for podspec template-based resources, not a complete black box general, you can put anything in there, but a fairly general things for a lot of, controller, including, in-house, like CRDs that we have that also follow this design principle. We do more than that. Something may be topic for another course. We do things about failure recovery, fault detection, fault recovery in app wrappers that are kind of optional, right? But also are one of these gaps we see between app wrappers and Q. So I'm very happy to share more about that some other time, or through questions about this. But just kind of separable for, again, the main things in the design I've talked about today. We did spend some quality time trying to understand how we would extend Q without forking Q. So actually, initially you pointed me to these examples that we're doing that already. So that was very useful. Thanks. And so, our assessment of that is works well enough, except for, this one design architecture question, which is this parent-child mechanism that, as you just said, exists in multiple forms. Clearly, you and other people have been thinking about, but not taking all the way, I think, to make it into reusable mechanisms. We'd like to do that. We also found, and I'm not going to, just at the eye level, I think we found a small number of issues with Q, but we're still investigating. So before we open bugs, before we bother people with them, before we do PRs, we really want to make sure our findings are totally solid. Just to give you a preview, maybe what we think we found is that today, if you have a PyTorch job supporting Q, you have, of course, a PyTorch job reconciler inside of Q and a Q reconciler, right? These are two separate threads, two separate things. But the way it's structured, because this is part of the upstream project, they run in the same process. They share the same controller runtime instance. In particular, they share the same Kubernetes client and they share the same cache of the Kubernetes resources. When we built these exact same, if we were to take that thing and run it as a separate process, you end up with two controller runtime instances, two client, two caches. And we think there are some corner cases in Q where the notion that these two caches, or there are some implicit assumption that these two caches are consistent, right? Are exactly at the same content. There's a bit of maybe missing robustness about handling reconciliation errors that will happen, when these things run separately. So I think that's what we're on track of fully understanding, and as soon as possible, we'll share with the community and hopefully fix those things so that it's truly possible to run this separately, to run a Q generic reconciler separately, as a separate thing, so as a separate controller, separate process, separate container, whatever. But having said that, again, the key takeaway, we very much like to contribute all of these things to Q. We'd like to have the app wrapper piece, generic reconciler for app wrapper be added to the list of frameworks that Q supports out of the box, with Rejob, PyTorch job set, and so on. We'd like to participate at least to a discussion of how we do this sub-resource management with Q going forwards. And definitely we're planning to, whatever we find, small things we find, we're planning to contribute to Q as well. And that's it for me.
Oh, thanks a lot. Does anyone have any questions?
I have another comment.
Mhm.
So to me, the idea of having a robust extension to Q that is not part of Q is very satisfying.
Mhm.
The idea that you can extend Q without forking anything, and it just works. Even just the the how's it called, the job reconciler that would translate an app wrapper into a workload.
Mhm.
We hope that this can always be built outside of Q.
Mhm.
And if it doesn't work, yes, we should try to fix whatever issue is there. So on the other hand, I see this app wrapper as something that a lot of people would benefit from. So maybe it makes sense to also merge the entire thing into Q. But I guess we don't have to take that decision now. For the time being, I think I would like to entertain the idea of having it work robustly as a separate project with all the support you can have from us. I think that would be a very nice story for us to show that these integrations are possible without forking.
Okay. Yeah, I agree. I mean, both are useful. I mean, what we'd definitely like to see at the very least is, Q include app wrappers as a supported thing, whether it's, through a restructuring of the repositories or not, right? So as long as people can find app wrappers and know that the batch working group, the core Q maintainers, recommends using Q if it matches the use case, then I think that would also, that would be a way to, as you said, start, right? And then we can go on from there.
I'm not an expert on Q. Probably Aldo or Michał or Martin are better than that. But I'm seeing that Q also has tabs for a lot of architectural decisions, or generally describing those kinds of patterns. I think it would be very beneficial for the Q project and probably for future uses to describe the ability to expand Q and build on top of Q mechanisms such as app wrapper, and you would could nicely point app wrapper as an example of this is how you actually can expand the Q, and within that document describe the current limitations and the path forward, because that would be a nice central point also to guide the future work and what needs to be done, and eventually further over describe those mechanisms and how people could actually build on top of Q, adding the necessary functionality that is missing currently.
Sure, agree.
Awesome. Does anyone else have any additional questions, comments, suggestions?
Maybe I will also ask or comment. I also like the idea that Q is extensible, like very much like this idea. I'm wondering, you mentioned that there is this mechanism for job set and job to maintain the relationship, child parent. And this works, but only works because the mechanism is inside Q repository.
Yes.
If I remember correctly, this whole mechanism is now based on owner references, and it's in webhooks, right? I'm wondering if you could also deliver webhooks that do mimic what we do inside Kube repository. I'm wondering why we have this limitation.
So the problem with the owner reference at this point in time is at some point, Q asks, do I manage the parent object, the parent object kind? Is it something I manage? And the answer is through the static list of things that are linked with Q, right? That are jointly compiled with Q, right? And so it would have to be, if we were to, so I have two concerns with that. It doesn't work today or I have three concerns, actually. First concern, it doesn't work because this mechanism is not extensible. There's no notion that these list of things that our Q supports is dynamic, right? So it could be made dynamic, I guess. It could be made something that can be extended. Maybe the admin can have a config map that describes this. That might be good enough to solve that particular problem. The second problem, and there, I mean, Dave is a better expert than myself because it's really, he worked on all these, attempts, right? He tried all of these things, to take them out as far as he could until he reached the point where he concluded this could be done. I'm not sure exactly how the job and job set thing and the relationship with owner references. One concern with that I have on the slide here that I understand is that so far there's been a one-way communication in these owner references. Essentially, I think there's a mechanism to say if the child appears, it will be suspended if the parent is suspended. But there's no, generic mechanism that says once the parent is unsuspended, then the child should be, right? I think that's one part of the problem. The last part is owner references concerns me in terms of abuse, right? I can go in and I can declare myself owned, right? So if I can say, look, I belong to this other workload, and suddenly Q says, oh great, therefore you can run. That's not okay, right? That's something that can be abused. I'm not 100% sure this is possible with everything today, but I strongly suspect this is a possibility, right? So we go a little bit farther than saying, we want a mechanism that is user friendly, but we say we also want a mechanism that precludes from involuntary or voluntary attempt at exceeding your quota. And so I think it doesn't solve that particular problem.
Okay, cool. So I would very much support collaborating on this.
Okay, great. So we can Slack offline on how to proceed, right? I guess, or we have a few minutes left.
I would
and I'm very
issues in GitHub.
Oh, and I just wanted to conclude that I'm also very much interested in the other topic that you just briefly mentioned, but we talked about at KubeCon, about resetting, reusing a finished job.
Yes. So yes, this we did what we did also based on our discussions. So maybe if there's nothing else, I can spend 2 minutes talking about this, right? So one of the I guess what we see in our use cases with these in particular large language model workloads is that they're long running, large, and so they're not constantly monitored, or admins or users don't want to constantly monitor the jobs. So we want the clusters. So we want mechanisms to do as much as the monitoring in a built-in manner. Right, and we face multiple issues there. Some of them are job failures. Some of them are actually node failures, cluster failures, GPU failures, right? And so what we used to have in MCAD is the ability to say, if we detect a job failure, or we're told through some external monitor that the job has failed, we're going to clean up we're going to wait some, because for instance, the PyTorch job might the training operator might be able to recover an unhealthy job by itself, right? So we let that, we give that a chance to happen, but it's also, for large job, for instance, the training operator doesn't always successfully recover a job. So eventually, if we decide that a job cannot be recovered as it, doesn't recover by itself, put it that way, we want to get rid of the job and recreate the job. And that makes sense for all of these jobs we have, which are checkpoint based. So when you recreate the job, essentially it resumes from the last checkpoints. That's the design pattern in those training jobs in particular. So yes, we had the discussion with you before whether, but essentially at this point, we build this as a separate capability from Q in this proper controller. In that case, what I had before on the slide is we go, and if we detect the job is unhealthy, we go resetting the job and eventually resume the job. So this is transparent to Q because from Q perspective, we never release the quota. We never reacquire the quota. That's one way to do it. That's not the only way to do it, but that's the simplest orthogonal way of managing that separately from again, without forking Q, without making changes to Q. I think an alternative, if the community is willing, would be that Q has a mechanism to requeue things when they fail scheduling. If we had the option to tell Q, look, something happened after scheduling was successful, after the pods were ready, but which requires the same essentially requeuing mechanism, which could trigger the same requeuing mechanism, we could envision other solutions. But right now we do this at the level of the proper controller, right? And yeah, so that's I guess as short a description as I can. So if that's of interest to go through the use cases, to go to the possible design. One other design we discussed was to have something that's before Q that submits the job to Q, unsubmits the job to Q, resubmits the job to Q. But from the way we built our end-to-end systems with front ends, UI, and so on, that's for us, that's not a reasonable solution. Essentially, that breaks assumptions about job IDs not changing over the time of the execution and a number of things. If that's of interest, I'm happy to.
Yeah, it is of interest because it's related to what we currently do with job, for example, that we block resetting of the status.
Yes,
and this was the decision because we thought no one would need it. But yeah, it would be nice to dig deeper into this subject.
It's also related to the other discussions about how you report not just changes to the status, but actually the reporting structure, right? These discussions about error codes and so on, because how do we know that the job has failed? How do we know also something that's very important to us? How do we know that this failure is likely transient or likely persistent, right? Is it worth retrying the job or not, right? That's a very important question here, of course, right? And with a black box solution, the best we can do is say, well, we'll try a few times. But the more specifics we have about the kind of failure, and the better we can go after it. What I like to say also is we have a lot of discussions internally about whether or not this makes sense to be done at an app wrapper level, or whether the PyTorch job controller should do a better job at that, or the RAID controller should do a better job at that. The answer is a bit of both, I think, because for instance, one thing that the app wrapper controller does is it deals with things like node failures, and the fact that if a node fails, even deleting a pod doesn't always work, and you need to force deletions. You need to do cleanup operations, for instance, that don't quite fit in a workload specific kind of operator. But that's also so we can have a discussion of where this fits between Q and something like a proper. We also have discussion on the other side where this fits between the workload controller themselves and the app wrapper controller.
Thanks, everyone. We're already at time, and I see Andre put a topic about consolidating job set and Kubeflow training operator. Andrew, is it okay to push this over to the next time?
Yeah, it's fine, I think. I mean, we can just visit or we can discuss it next time as well.
So just for everyone, the topic and the document is linked in the agenda. I'll bump it over to the next week. So by that time, people will have a little bit more time to go through this doc. Okay.
Yeah, so should I just give a context so people can review?
Yeah, go ahead.
Yeah, so hi everyone. Like I'm Andre, I work at Apple. I just want to introduce myself. Like I'm part of Kubeflow community, been there for the last almost 6 years. And we try to collaborate with Batch Working Group to see how we can move forward to these new initiatives around job set and how the training operator should live together with the job set. And the thing is, like, just to give you a little bit of a background, right? Originally, Kubeflow was a project which was open sourced by Google in 2017, which gives the user an ability to run TensorFlow jobs on top of Kubernetes in a simple way. So it was even before Kubernetes has the customer source concept. So this project got evolved for the like recent years, and we implemented new supports for other frameworks like PyTorch, Paddle, MXNet, JAX, MPI, not JAX, but MPI, Paddle, and other frameworks, right? And the problem is because our frameworks, our operator lives in a separate repo, we try to unify them in a single repo, and we try to build a unified training operator which can handle all of different sub-resources. Like as Oliver mentioned about PyTorch jobs, also TF jobs, also API jobs, and other things. So right now we try to see how, because JobSet basically can cover most of the use cases from distributed training, but we have few concerns that we should discuss, and we try to like summarize them in the doc. And just to see what is the future of Kubeflow should be there and what is the future of JobSet should be there. So we can consolidate our efforts and build a unified solution for data scientists to do ML training on Kubernetes in a very simple way. Because there are several concepts we should discuss, and I'm looking forward. Maybe we can do it next week. All right.
Okay, yeah, that's definitely helpful for a lot of folks too, as a primer for the next time. With that, thank you very much, everyone, and enjoy the rest of your day. See you next time. Bye, all.
Thank you.
Thank you.